Welcome to The Explainer. Today, we're going to crack the code. The one scientists use to classify every single climate on Earth. We're talking everything from the hottest desert all the way to the frozen poles.
I mean, think about it. Why is the Amazon this lush green jungle while the Sahara is, a huge barren desert? It all boils down to climate, right? But with so much variety out there, how in the world do you even begin to organize and compare all these different weather patterns in a way that actually makes sense?
Well, the answer really lies with one person, a German scientist named Koppen. And back in the early 20th century, he had this totally revolutionary idea. He thought, instead of just staring at weather charts all day, what if we classify climates based on something we can actually see? The plants! What kind of vegetation can grow and thrive in a place? It's a genius idea, really.
Now, this wasn't some idea he just cooked up overnight. Nope. His system was carefully refined over decades. But the core idea always stayed the same, focusing on the two things that matter most to any plant: temperature and rainfall. It's that simple.
Okay, so here's our game plan. We're going to start with the 5 main climate families. Then we'll add the all-important details about rainfall. After that, we'll take a quick global tour to see it in action, with a special stop in India. And finally, we'll talk about why this system is still such a big deal today. Ready? Let's do it.
Okay, first things first. The whole system is built on just 5 simple groups. Seriously, that's it. Think of them like the alphabet of climate. A, B, C, D, and E.
All right, first up is the letter A. A is for tropical climates, and what that means is it's warm all the time. The key thing to remember here is that winter basically never shows up. Even the coldest month of the year is still a pretty comfy 18 degrees Celsius or higher.
Next on the list, B for dry climates. Now, this is important. It's not just about how little rain falls. A B climate is a place where there's a serious moisture deficit. In other words, more water evaporates than falls from the sky. And that's what gives us the world's deserts and steppes.
Now we've got C, which stands for temperate climates, and you can think of this as the Goldilocks zone, Not too hot, not too cold. You get real seasons for sure, but the winters are generally pretty mild, not super harsh.
All right, moving on to D for continental climates. And the key word here is drama. These are places with really dramatic temperature swings between summer and winter. We're talking long, cold, snowy winters. And a fun fact, since you need a huge landmass for this to happen, you'll pretty much only find D climates in the northern hemisphere.
And last but not least, E for polar. As you can probably guess, these are the coldest spots on the planet. I mean, even the warmest month is still pretty chilly. There's no real summer to speak of. And that's what creates those incredible landscapes of tundra and giant ice caps. So, you see, that first letter is so important. It gives you a really quick, big picture idea of what a place feels like, temperature-wise, all the way from the tropics to the poles.
But look, temperature is only half the story, right? To get more specific, Koppen added a second letter, a lowercase one, to talk about rain. This second letter is all about timing. When does the rain actually fall?
And this is where it gets really cool. Just one little lowercase letter can describe 2 totally different places. For instance, an S means a dry summer. A W means a dry winter. Think about it. That's the difference between a golden, sun-baked hillside in California in July and a dry, dusty savanna in Africa in January, all in one letter.
Okay, 2 more to round things out. If you see an F, that means it's fully moist. Rain pretty much all year round, no real dry season. But M is special. That's for monsoon. You might get a short dry season, but then, bam, it's just completely overwhelmed by these incredibly heavy, drenching rains.
Okay, so we've got our letters. Now for the fun part. Let's start putting them together. This is where the code really comes alive and starts painting a picture of real places all over the globe.
Let's take an easy one. You take A for tropical, and you add F for rain all year. What do you get? F. And that, my friends, is the code for a tropical rainforest. Always hot, always wet. Think the Amazon or the Congo Basin.
Or how about this one? You take C for temperate, and you add that S for a dry summer. Put them together, you get CS, and that's the signature climate of the Mediterranean. Those amazing warm, dry summers and mild, rainy winters. You see the same thing in places like Central California, too.
Now, to really see the power of this system in action, let's zoom in on one country that has an absolutely incredible range of climates. Let's take a look at India.
Wow, just look at this map. It really shows you how many completely different climate zones can be packed into one country right next to each other. It's pretty amazing. The system is so detailed it can capture all this variety.
Okay, check out the western coast there. It's coded AMW. This is your classic tropical monsoon climate. So it's hot all year, but it gets absolutely hammered with rain during that southwest monsoon season.
Now, shift your eyes over to the northwest, to that BWH zone. This is the Thar Desert, and it couldn't be more different. We're talking a true hot desert climate. There's almost no moisture, and the summers are just scorching, with temperatures that can climb up to 50 degrees Celsius. A world away from the coast, right?
So you can see how powerful this is. But here's a question. The system is over a century old. Why are we still using it? Why is it still the go-to for so many scientists? Well, let's quickly look at its pros and cons.
Okay, so the beauty of it is its simplicity, right? It's simple, it's based on numbers, and it connects climate to what you can actually see, the plants. But it does have a downside. Critics will point out that it's really good at describing what a climate is like, but it doesn't tell you why. It doesn't explain the big picture causes, like global wind patterns and things like that.
But at the end of the day, this simple code is so much more than just a bunch of letters on a map. It's like a language that helps us understand the amazing climate patterns that shape our entire world. Which brings up a fun question. What about where you live? What's your code?